We're going to start chapter 8 today, and chapter 8 is about concepts of chemical bonding. In other words, how do you form a bond? How do you make compounds? Um, the thing to remember about compounds is they're made from electrons. The bonding occurs with the electrons. Okay, that's where it has to happen. That's why it's important to know where the electrons are. There's three different types, basic types of bonds that can occur. One is ionic. And ionic, there's an attraction between ions. Basically what happens is electrons are transferred from a metal, to a non-metal, and then you form these ions, your cations and your anions, and then they're attracted to each other because they're positive and negative. Then there's covalent. Okay, covalent is where you actually share electrons. They form molecules. Okay, they don't transfer electrons. Instead, they stick together and they share their electrons. Because when you form a bond, the magic number is 8. They want a full outer electron shell, and that's 8. That's called an octet. And the other one's called a metallic bond. And we're not going to spend too much time talking about a metallic bond, but a metallic bond forms between metals. Okay, they're different. They're unique because the electrons get to move wherever they want. It's kind of like if you had a block of like 10 houses and the kids could live in any house they wanted to, everybody could roam around. That's kind of like a metallic bond. So we're going to spend more time talking about the ionic and the covalent. But again, those are the three types. Okay, and it's easy to tell. Ionic occurs between a metal and a nonmetal. Covalent occurs between two nonmetals, and metallic form between two metals. Okay. All right. When you're figuring out what type of bond they're going to form, you can demonstrate it through what they call a Lewis structure. And the guy, G.N. Lewis, I can't even remember what his real name is. George, I think, is his first name. Anyway, he developed a method for denoting the electrons that are available to form bonds. Okay, so if you look here, lithium has one dot. It has one electron available to form a bond. And really, it's whatever group they're in. Okay, if you go by the S and the P's. Okay, those are the main groups. Those are the ones where you can tell the valence electrons. Okay, so we got lithium with 1, beryllium with 2, boron with 3, carbon with 4, nitrogen with 5, again, oxygen 6, 7, 8, and all the ones below them as well. And these are the noble gases. They don't form any compounds because they already have 8. 8 is the magic number. So these guys with 7, they are really looking for 1 because, then they'll be stable. The guys more in the middle where they have like 4, okay. And again, when you're talking about forming bonds, these metals are going to give up their 1 to these that need 7. So if it's between a metal and a nonmetal, it's going to be ionic. If it's between two nonmetals, it's going to be covalent. Okay. When forming compounds, okay, they do a couple different things. Again, if it's an ionic bond, they're either going to gain electrons or lose electrons. So in other words, electrons are transferred from one to another, or they're going to share electrons. And again, the magic number is 8. When they have 8, they are stable. That's called the octet rule. And that's why the noble gases are all stable, because they have 8. But again, you can tell how many electrons they have available by what group they're in. Okay? So again, when we're talking about ionic bonding where they transfer electrons, that's between a metal and a nonmetal. Okay? They transfer electrons. The metals, they're very giving. They will give their electrons up and they'll give them to the nonmetal because the metals have 1 in there, or 1 or 2 in the outer energy level. Well, do you pick up 7 or 6, or do you get rid of 1 or 2? It's much easier just to get rid of 1 or 2. So then it'll go down to the next level, and that level will be full. And the nonmetals have like 6 or 7. Okay. Again, it's easier for them to pick up 1 or 2 than it is for them to get rid of 6 or 7. So they'll pick up an electron and fill their outer energy level. And what ends up happening because of this transfer is now you have ions. Because remember, in an atom, the protons and the electrons are the same. But now when you got electrons moving around, now the charges aren't going to be the same. So the nonmetals become positive because they give up electrons. That's a cation. And then nonmetals they pick up electrons, so they become negative. They have more electrons than protons, and they become anions. Okay, and here is showing a transfer. Oh, this is sodium and chlorine. If you've ever watched this reaction, it's crazy because sodium is just this little soft metal, and you put it in chlorine, and it's just very explosive. You actually have to put sand in the bottom here, because if you don't, the glass will break. It's really a highly exothermic. It gives off a lot of energy, and then you end up with salt. Okay, so most of the ionic bonding, when it forms, it's very, very exothermic. It gives off a lot of heat. Okay. Okay, so ionic bonding. Let's talk about ionic bonding. One element is going to give up electrons. That's going to be your metals. They have they have an energy. It's actually calculated for every element, and the ionization energy is how much they want electrons. If it's low, they don't want electrons. If it's high, they want electrons. Okay, so let's see. You're going to have one, like sodium here. Sodium only has one electron, and remember, it needs 8. So it has a choice. Give up this 1 or pick up 7. See, because if it gives up 1, then you go down to the next level, and that will be full. That'll be like a noble gas configuration. So give up the 1, and now it's good. But because it gives up 1, it has a positive 1 charge, because it gave up 1 negative charge. And then chlorine is looking for 1, so it's going to give up, it's going to take in that electron, and now it'll have a negative 1 charge. So you made ions, okay? And the chlorine is going to have a high electron affinity, or it's going to have high ionization. It really, really wants electrons, okay? And the nonmetals, not so much, okay? And you can see the transfer. Again, 1 electron is transferred to the other. Now this one has 8, and this one, because it has 0, goes down to the next level, and it'll have 8, and then they're both stable. And what you have to do is put in the charges now, because they're ions, okay? If you look at it in a 3D structure, this is a crystal of salt, sodium chloride. The blue are your sodium ions, and the green are your chlorine ions. Now, because sodium's positive, all these chlorine negatives are going to be attracted to it, and so on. So they stay together. A covalent bond is a very strong bond because of that attraction. The things to remember about ionic substances, and again, these are all your salts, not just sodium chloride, but all the salts. You know, lithium bromide, potassium iodide, all of those are considered salts. Okay, it's a metal and a non-metal, and those halogens, that group 7. But anyway, they're very brittle. They have high melting points. If you try to melt salt, like with a burner or whatever, it's not going to happen. Okay, they're crystalline. They have the same exact structure. If you ever get bored, you can look at salt crystals. They all look the same. When they cleave, that means when you break them into parts, if you look here, they have like places for them to break up. Okay, so that's, you know, that's what happens with an ionic bond. Okay, when you make an ion, when you transfer electrons, you look at ionization energy. It's the energy, you know, the higher the number, the more they want electrons, the lower the number, the less. And then they also have what they call electron affinity. That's another number. And electron affinities, how much do they want electrons? So really, high ionization, high electron affinity, those are going to be your nonmetals. Low ionization energy, the energy it takes to get rid of an electron, and how much do they want electrons, electron affinity, it's going to be low for metals. Okay, it takes energy to convert the elements to atoms. Okay, so if you're going backwards, then it's endothermic. Okay, and if you're going to create a cation, if you're going to create ions, it's if you go backwards again, it's endothermic. But if you're making an anion, so in other words, if you're going to make a cation, remember, cation's giving up one of its electrons, so it's going to be a lower energy. That's why it's endothermic. If you're making an anion, you're adding to it, so that's exothermic. So the non-metal part, okay, that's going to be exothermic. The metal part is going to be endothermic. Okay, and whenever you form a solid from these, like again, when you form a salt, there's a huge amount of energy. Like I said, when you put sodium and chlorine together in a container, you have to put salt in the bottom of the container to absorb some of the heat energy. Otherwise, the glass will break. Okay, so whenever you make a salt, if another one that's really crazy is potassium. Potassium is even more reactive than sodium. If you put potassium on an ice cube, it will make the ice cube burn. It's really kind of cool to watch an ice cube burn. Okay, so those are, you know, things that happen with ionic bonding. Okay, look at my time. Okay, your main group metals, they lose electrons. Again, the ones in the first row, lithium, potassium, sodium, and then the next one where you've got like magnesium, calcium, all those guys all like to lose their metals. And I mean electrons, excuse me. The metals lose electrons, and the reason they do that is they only got 1 or 2. It's just easier that way. Okay, the nonmetals, because they have much more on the outside, they have 6 or 7. They need to pick up electrons. Okay, they need to gain electrons. And again, that's how they get their 8. That's the magic number, 8. They have to have 8. Okay, the transition metals really don't follow the octet rule, so we're not going to count them when we're looking at ionic bonds. Okay, they're just no patterns. There is with the S group and the P group. With the D group, there's not a pattern that you can follow, so we're just gonna blow them off and work on the ones that we can deal with. Okay, sometimes they lose them first, sometimes, you know, there's no pattern involved. So because they can't make up their mind what they're going to do, we're just going to ignore them. We're just going to go with the S, the first 2 groups, and the P's, the last 6. Okay. All right. Now that's ionic bonding. Now what happens if they're not going to transfer electrons? What if you got 4? Do you give up 4? Do you pick up 4? You don't do either. Instead, what you do is you share electrons. Okay. I think this is supposed to be hydrogen. Okay. When you form a bond, like the diatomic elements, hydrogen, chlorine, iodine, all those guys, what they do is they stick together and then they have a concentration of electrons in between them. In other words, they're sharing those electrons. This one isn't giving this guy an electron. This one isn't giving this. They're not giving them up. Instead, they stick together and then they share their electrons. And this is called a covalent bond. Okay. There's an attraction between the nucleus and the electrons on both sides. Okay. And then there's a repulsion between these. So in order to form a covalent bond, the electrons are shared to get 8. And because they do that, they have to stick together and they form molecules. So ionic bond form ions, covalent bond forms molecules. Okay. And again, in a bond, if the bond is going to form, the repulsive forces have to be greater. I mean, the attraction forces, sorry, I'm saying that backwards. The attraction forces has to be greater than the repulsive forces. So if these guys, there's a stronger force between the electrons and the nucleus on these sides than there is between these 2 nucleus trying to push each other apart. So if they overcome that, this force of attraction is greater, then they stick together and they form a molecule. Okay, but they have to share their electrons in order to be stable, to get 8. Okay, now when you form a covalent bond, like if you form a covalent bond between 2 hydrogen, obviously they're going to share the electrons in the middle because they have the same repulsive force the nucleus do. But if you do one between hydrogen and chlorine, chlorine has a much stronger pulling force. You know, the nucleus has way more protons than hydrogen. So what's going to happen is the electrons are going to be pulled closer to the chlorine than they are the hydrogen. And because of that, you're going to end up with what they call poles, a positive end and a negative end. So they share the electrons, but they don't share them equally. Okay, so when you have covalent bonds, you can have nonpolar, where they share the electrons right in the middle, or you can have polar, where they're closer to one nuclei than they are the other. And then again, you end up, even though overall the charge is 0, you end up with a positive end and a negative end. And the most common substance and the most important substance that does this is water. Water is very polar. That's why water is such a great solvent. It can pull things apart because it has a positive end and a negative end. Okay, so in a nonpolar covalent, again, they're sharing the electrons and they're sharing them equally. You find them right in the middle. But in a polar covalent, one of the atoms that has it basically has a bigger nucleus, and so it has more protons, so it's more positive, so it pulls the electrons closer to it. So you're going to end up with a positive end and a negative end. Okay, and that's a polar covalent bond. And actually, more bonds are polar covalent than anything else. That's the most common type. Okay, what do we got here? Okay, so here we have fluorine. Okay, fluorine is a diatomic element. In other words, when it's by itself, when it's pure, there's 2 fluorines stuck together. Okay, and what they do is they share 2 electrons here in the middle, and they both get 8 that way because one fluorine has 7, this fluorine has 7. If they share 2, they both have 8. Find the electrons right in the middle. Okay, on this one, hydrogen and fluorine, hydrogen is much smaller, obviously, than fluorine because fluorine has 7 electrons and hydrogen only has 1. So the electrons are found more on one end than they are the other. So this ends up being a positive end and this being a negative end. So this is a covalent bond. They are sharing the electrons, but they're not sharing them equally. And then this represents an ionic bond. Lithium will give its electron to fluorine. Okay, so there's no sharing going on here. They're transferring them. Okay, So again, the fluorine pulls harder on the electron